All right. Now we're going to look at radical equations. So just equations that have square roots in them. It could have cubed roots in them, any type of root really. I'm gonna split this into two parts. I'm gonna leave the steps to solving on the left. These I would qualify as kind of the easier versions, and the next video I'll do a little bit trickier ones. Okay. But the idea behind all of them is really how I get rid of this root. Right? Once the root's gone, I can solve this by any method that we've learned so far, whether it's just solving for x, whether it's a quadratic and I have to factor, whatever's left over we know how to solve, or we've learned how to solve to this point. So, and the first thing that we want to make sure happens, right, before we do anything tricky in the equation is to isolate the expression that has a root in it. Right? In all three of these problems, this is why I qualify these as kind of the easier versions, the expression that has a root in it is by itself. Right? Is by itself. It is by itself. Right? In the next video, we'll look at ones where they're not by themselves. Right? Just to show you what that would look like if I had square root of 2x plus 7 equals 10, something like that. Now my rooted expression is not by itself, this plus 7 is in the way, so we get rid of the plus 7 and work from there. So sometimes you have some algebra steps to do at the beginning to set the problem up correctly. Right, once it is isolated, we're going to raise each side of the equation to a power to cancel the root. So I don't want to distinguish between what power I'm going to use. In all of my examples, it's going to be the power of 2 because I want to cancel out a square root. But if it was a cubed root, I'd use a power of 3. If it was a 10th root, I'd use a power of 10. So choose the power that's appropriate to cancel out the root. And from there, we're going to solve the resulting equation. Right? Sometimes that's easier said than done. Right? Sometimes we're just going to have one step. Sometimes it might require us to resort to quadratic techniques. But we've definitely learned how to solve everything that's going to result from that. So let's take that and apply those to these three quick examples. Since they're all already isolated for the root, I can square both sides. And squaring a square root is going to cancel it out. So we have 2x equals 10 squared 100. Divide by 2. And we get our answer of 50. The last thing that I should add here is what we want to do when we manipulate an equation in this way, when we square both sides of an equation. Sometimes we actually create a solution that isn't a solution, a lot like in Mod 7 when we found solutions that didn't actually work. All right, so you should check your answers. To see if there's any extra answers that don't actually work. In here, usually pretty quick. If I plug 50 back in, 2 times 50 is 100. The square root of 100 is 10. So that works out. Confirmed. Okay, number 2. Okay, we can start by squaring both sides. All right, to cancel out the root. 16, and solve from here, subtract 4, divide by 3. So we've got an answer of 4, and again, we can double check pretty quickly. Plug in 4. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. So that checks out. Right. Nothing funky happened yet. Right, for the third one, again, I've got an expression that's being rooted and the whole thing is by itself. So I'm going to cancel out that root by squaring both sides. So this one we have to be a little bit careful about because now I'm squaring, make sure parentheses, notice I put parentheses every time. Right? I'm squaring this whole side, I'm squaring the 2, I'm squaring the x, and I'm canceling out the root. Now this equation is still solvable, but it's different. Now it's quadratic. We've got an x squared in there, so we have to treat it in the way we treat quadratics, which is make them equal 0. So subtract these from the right side, put it in standard form. Once it's in standard form, we're going to factor it. I don't see a common factor, so we'll unfoil it. And I think this is going to be 4x times x. I need to get to 19, so 5 back here should help. 4 times 5 is 20. With 1, 20 and 1, that'll be minus 5 plus 1, so that works out. And then each piece will give us an answer. Set that equal to 0, add 5, so we get 5. And this one gives us an answer of subtract 1, and then divide by 4, negative 1/4. A little bit harder to double check these, but with the use of a calculator you can plug them in and see if they work. If I plug in 5, 19 times 5 is 95. I'll go ahead and write this out. 2 times 5 is 10. Square root of 19 times 5 is 95. And then that'd be 100. Square root of 100 is 10, so that works out. Okay, the other one, if I plug in negative 1/4, 2 times negative 1/4 equals the square root of 19 times negative 1/4 plus 5. I can already see an issue happening here. When I multiply this, I'm going to get negative 1/2. And it doesn't really matter what's over here. I'm taking a square root of a number. When I take the square root of a number, I'm not going to get a negative. It does end up being, what's that going to be? Negative 19 over 4 plus 20 over 4. This would be 1/4. Right, but these two do not equal each other, because when I take the square root of 1/4, I get positive 1/2, not negative 1/2. So this answer actually is not a solution to the equation, whereas this one, x equals 5, is. So you do want to test them out. Okay, it's not always the case that every answer will work. So be back with a little bit harder examples, some that aren't isolated for the root, but we're going to take the same strategy every time.